Okay, so I think the session is being recorded, so please keep that in mind. Okay, so today in class, basically today we are going to talk about parabolas as conic sections. Okay, so we have the two cones stacked on top of each other, and if we cut the cone with the plane like this, then we can kind of see that we get a parabola as the result. Okay, now we know parabolas as equation as the graphs whenever we have a quadratic equation. So we know parabolas being written in a form like this: ax squared plus bx plus c. You don't need to write this one down, by the way. So this is what we usually can see parabolas as. Also in Algebra 2, you learned a vertex form that would have looked like this: x minus h squared plus k. Okay, so we've seen parabolas being written in this form. And this is perfectly fine, but that's when we look at the parabolas as functions. However, in class today for conic sections, we are going to look at the parabola as a conic section, and therefore it will have a slightly different definition from what you're used to. So, a definition of parabola is right here. A parabola is a set of all points that are equidistant from a line that's called the directrix. So it's this line right here. So it's named, and a point that's called the focus. So that's the point. So basically, all of the points on this parabola. So this parabola consists of a bunch of points, and they're all equidistant from the focus and the directrix. So in other words, this distance right here, from the focus to this point on the parabola is the same as this distance right here from this point to the directrix. And that's true for all of the other points. So like this point, this distance is the same as this distance. Now, they might not look like that on the picture, but in reality, that's the definition of the parabola. It's a set of all points that are the same distance from that point, that's the focus, and the directrix. Okay, now, so when we look at parabolas as conic sections, it has several parts. And also we have different versions of the parabola. Let's talk about the different versions first. So we have parabolas that open vertically. So that's what we see right here. We have a parabola that opens upwards, and then we have a parabola that opens downwards. And just like we've seen many times in Algebra 1 and Algebra 2. And if we have these parabolas that open vertically, then the equation or the form of the parabola will be like this. We'll have x minus h squared equals 4p y minus k. We're going to talk about what this h and p and k, what they mean a little bit later. However, we also can have parabolas that open horizontally. So this is going to be right here. So notice we have a parabola that can open to the right, and we have a parabola that could open to the left. If the parabola opens horizontally, then the equation, the general form, changes a little bit, and it has this form right here: y minus k squared equals 4p times x minus h. So please notice that if your parabola opens vertically, then it is going to be the x variable that is squared. If your parabola opens horizontally, then you have a y variable that's being squared. So you have two different versions of the equations depending on what kind of a parabola you have. And that would be important because we're going to be sometimes be given an equation, and then we will have to maybe graph the parabola. So by looking at the equation, at the form of it, we'll know which way the parabola will open. Or we might be given the parabola itself and we need to write an equation. And once again, depending on how the parabola looks, we'll write a different version of an equation. So, but there are two different forms. And just like everything in this class, you have to memorize these two different forms. They will not be given to you on the test. You need to know them. Okay, so right now let's talk about the parts of the parabola. So we are looking at the parabola in a slightly different light. We're looking at the parabolas as conic sections. So they have some things that we haven't actually ever considered when we looked at the parabolas in Algebra 1 and Algebra 2 classes. So first of all, the first part is still pretty similar to what we've done before. The parabola has the vertex. So a parabola will have a vertex right here, and the vertex will have coordinates h and k. So these numbers right here that we have in our equations, this h and k, these are actually coordinates of your vertex. And of course, it doesn't matter which way it turns, it's still your coordinates h and k. H is the x coordinate, k is the y coordinate. But then we also have other parts of the parabola that we haven't seen before, such as the focus. So we have this focus right here. Now, this is also going to be a point, and specifically, this point is a very particular distance, and we'll call this distance p. So in our equation, we can see this parameter p right here. So if you're wondering what that is, well, that p represents the distance from the vertex to the focus. But since by the definition, all of the points on the parabola are equidistant from the focus and the directrix, then very importantly, the distance from the vertex to the directrix, so this distance, is also going to be p. Now, this p-value also has another important property. If our parabola opens upwards, then p is a positive number. So this will be positive. But if it opens downwards, then p will be negative. One last thing that we have is we have the line that's called the latus rectum. That's this red line that you can see, and that's just a line that goes through the focus of the parabola and connects the points in the parabola. We're not going to spend too much time on this line, but you just need to know that that's part of the parabola as well. Now, this is for the parabola that opens vertically. However, if your parabola opens horizontally, all of the parts are exactly the same. So let's look at this one. So we still have the vertex, and the vertex still has coordinates h and k. So on both versions. We still have the directrix. Now notice though, the directrix in this case is going to be a vertical line. We still have the focus, and the distance from the vertex to the focus is still at number p. And once again, it's the same distance from the vertex to the directrix. This distance is also p right here. Now, just like with the vertical parabolas, p, the sign of p, whether it's positive or negative, will determine whether the parabola opens to the left or to the right. So if our p is a positive value, then the parabola opens to the right. And if p is a negative value, then the parabola opens to the left. So we have these types of parabolas. When we talk about parabolas that open horizontally, we of course can see that these are not functions because it doesn't pass vertical line test, but we are not concerned with these parabolas being functions or not. We're not looking at the parabolas as functions right now. We're looking at them as conic sections, and there will be a lot of applications to these parabolas when we consider them as conic sections. And we're going to discuss these applications a little bit later. Okay, so before we go on to the examples, please let me know if you have any questions. Once again, just unmute yourself. I don't think I can see any reactions when I'm sharing the screen. So if you have a question, please unmute yourself and just speak up. Okay. You can also write things in the chat, and I think I'll be able to see things in the chat as well. Okay, so right now we're going to start with our first example. And in our first example, we are given an equation of the parabola. So right here, we have this equation, x minus 4 squared equals 8 times y plus 1. And ignore this little line after 1. It's just a cursor that's got also copied. But so first of all, we can recognize in the form of this equation. Please notice that this is an equation in the form x minus h squared equals 4p y minus k. So that's the form of our parabola. We can see that the x term is the one that's being squared. And since x term is the one that's being squared, we know that the parabola will open either up or down. It's going to be vertically opening parabola. And since this 8 is a positive number, that means that our p will be positive. Therefore, this parabola will open upwards. So by looking at the equation, when it's already in the standard form, we can see that the parabola will be opening up. So now we need to, first of all, find the vertex of the parabola. Remember, the vertex will be coordinates h and k. And, well, these are the numbers from the parentheses. So our h is the number next to x. And please notice that the minus is part of the equation. So h is just this number, is just 4. Notice we're not going to use it as -4. It's going to be positive because the minus is part of the equation, not part of the 4. Similarly, with the k, notice that in the form, it should say y minus k, but we have y plus k, y plus 1. So that means that it's really y minus -1. So once again, we basically have to change the sign of our number. So our y coordinate would be -1, not +1. So in other words, just like we've done many times in the past, whenever you're writing your h and k, you have to switch the signs of those numbers. Now we're going to plot 4 and -1 on the graph. So this is our vertex, and I'm going to also label this as a vertex with a little v so we don't forget what this point represents. Now, from here, we should be able to, next we'll find the directrix and the focus, but the direction in which the parabola opens is very important to us because when we have only one point, the parabola can really open in any 4 directions. But by looking at the form of the equation, we already know that the parabola will open upwards, so I will draw this parabola. So we're not concerned with drawing it very accurately. We just want to know the direction. Then we need to find the directrix. Remember, directrix is a line, and think of the parabola as kind of like a Pac-Man. So if we look at our pictures, we can see the parabola that opens vertically. So if the parabola opens vertically upwards, then the directrix always on the opposite side of the parabola. So regardless of which way it opens, actually, it always on the opposite side of the parabola. So parabola kind of like runs away from the directrix. We can also see this when it opens horizontally. So the parabola is kind of like a Pac-Man, and it always runs away from the directrix. So therefore, our directrix will be somewhere below the parabola. Now, how far below? Well, remember that the distance between the vertex and the directrix is this value p. So we need to find this value. And here we can look at our equations, and we can see that 4p is the value in front of the parentheses, which in our case is 8. So therefore, it turns out that our 4p, actually I'll do it over here on the side. So 4p is the same thing as 8. So these are the values. So this 8 represents this 4p. Therefore, we can solve this. We divide by 4, and we get p equals 2. So we know the distance from the vertex to the directrix. It's 2 units down. So p equals 2. So we go 1, 2. So this is where the directrix is. And remember, the directrix is a line. In this case, it's a horizontal line. So this is our directrix. Now, to write an equation of a horizontal line, we should remember that it is going to be y equals the y-intercept, which in this case is -3. So the directrix, remember, it is a line, therefore it has to be written as an equation of a line. Finally, the focus. Well, if we considering our analogy of parabola being a Pac-Man, the focus is like a pebble that the Pac-Man eats. And remember, it is also, I'm going to scroll back up, the distance from the vertex to the focus is still this value p. So we already know that p is equal to 2. So from the vertex, we're going up to 1, 2, and that's where the focus is. So this point right here is the focus. This distance is p equals 2. So, but focus is a point, it's not a line, therefore it will be described as an ordered pair. So in this case, it is 4, 1. So the focus is 4, 1. So it's an x and y coordinate. So therefore, we were given the equation of the parabola in standard form. We were able to find all 3 parts of the parabola, such as the vertex, directrix, and the focus. And meanwhile, we were able to graph the parabola as well. In fact, even if you're not asked to graph the parabola, it is always a good thing to sketch the parts of the parabola, because that helps you to find your parts, your components. Okay, before I move on to other examples, once again, please unmute yourself and or write in the chat if you have any questions. Okay, then I will continue. So now we're going to look at slightly different questions. And our next question is we want to write an equation of the parabola, and we want to write this equation by being given the vertex and then also the focus. So we're given now the parts of the parabola, and we want to write an equation of it. Well, as I mentioned earlier, sketching the graph is going to be very useful to us. So that's what I'm gonna do right now. And second, I don't like that. Okay, so let me draw the coordinate plane. So we're going to draw our coordinate plane and put some intervals on it. Okay, so the reason why I drew this is because right now I'm going to plot the points that are given to me to plot the information. So we know the vertex, which is -1, 2. So this is -1, 2 is this point right here. That's our vertex. Then we also know the focus, which is -1, 0. So -1, 0 is this point, and maybe I can use a different color for it. Let's say green. And that's the focus. Now, why is this important? Why is it important to plot these points? Well, remember, our parabola is basically a Pac-Man that always eats the focus. So by looking at this, we can determine the direction of the parabola. We see that the parabola has to open downwards. And that's extremely important to us, especially when we want to write an equation, because that tells us which form of the equation we have to use. Since the parabola is opening downwards, scrolling back up to our pictures, that's this type of the parabola. Therefore, the equation will be in this form: x minus h squared equals 4p times y minus k. So we know the form of the parabola now. Now from here, we need to figure out our 3 components. We need to know what is h, what is k, and then what is p. Now h and k are pretty simple in this case because they're already given to us. Remember, your h and k are coordinates of the vertex, which is given. So we have the vertex -1, 2. These are our h and k components. Therefore, we already can write this as x minus -1 squared equals 4. We don't know p yet. We're going to find this out here in a minute. But so I'm going to keep those parentheses open, but then it's y minus k, which is 2. So this is what we have right now. When you have x minus -1, you of course can write it as a +1. Ooh, sorry about, thank you for letting me know. Bye. Sorry, I accidentally pressed on stop share when I was writing. So I will move this over. Yeah, sorry about that. Thank you, Solar. So we have this equation. So we have x minus -1, which of course will become x plus 1. But right now we are concerned about how to find this p. Well, remember that your p is the distance from the vertex to the focus. So this distance right here is p, and of course this distance is 2. However, since we're going facing down, p will be equal to -2. And that's because the parabola is facing down. And we already talked about how if the parabola is facing down, then p will be a negative number. Okay, and therefore we're going to put -2 right here. And now from here, we just need to simplify everything. So it's going to be x plus 1 squared equals -8 y minus 2. And that's it. That is our equation in standard form. We don't really need to do anything else to this equation. Okay, let's do 2 more examples. For number 3, we want to write an equation in standard form again, but now we're given the vertex and the directrix. So once again, we want to start by graphing our parabola, by plotting those points. Okay, so we have the vertex, which is -1, 2, so it's actually the same vertex as before. But then we're given the directrix, which is x equals -2. So remember, if we have an equation of x equals a number, then it's going to be a vertical line. So it's going to be a vertical line like this through -2. So we're going to draw our directrix, and that's x equals -2. And once again, this tells us which direction the parabola opens, because the parabola is like a Pac-Man. It runs away from the directrix. So if the directrix is on the left, then the parabola has to face to the right. It has to face this way. And by looking at that, knowing that the parabola faces to the right, which means it opens horizontally, we changing the form of the equation. For horizontally opening parabola, the equation is going to be y minus k squared equals 4p x minus h. So notice this is a different form from what we had in the previous example. So the previous example, the x component was squared. Now it's the y. Now from here, a lot of things are still the same. We need to know h and k, well, which is our vertex. So erase this line. So this is our h and k. So be careful. Notice that k is always going to be the y coordinate, or in other words, the y coordinate always goes with y. So therefore, it's going to be y minus 2. So please be careful. Don't mix those up. It's a very common mistake. So the y coordinates goes next to y equals 4. We do not know p yet. We're going to find it in a minute. And then x minus -1. Now to find p, well, we don't know what the focus is in this case, but we do know the directrix. And remember, p is the distance between the vertex and the directrix. Ooh, what happened here? Oops, I have no idea what just happened. Sorry about this. That's right. So it's the distance between the vertex and the directrix. So P is equal to 1. Now notice it's going to be positive 1 because parabola is opening to the right. So if we once again look back at our notes, if the parabola opens to the right, then P is positive. If it opens to the left, it's negative. Since it opens to the right, it's positive. So we're going to put positive 1 as our P. And then finally, we simplify everything. Y minus 2 squared equals 4x plus 1. Okay, so that is our equation by being given the vertex and the directrix. Before we move on to the last example, here's just a little side note about your practice on delta math. So on delta math, I clearly do not give the format there. So on delta math, you will have questions like this, where you, let's say, are given, no, like, let's say the vertex and the focus. So let's say we have the vertex of like 2, 3, and then you are given, let's say, the focus of, let's say, 2, 0. Okay, so you need to find P, what P is equal to, and so on. Now on delta math, even though this parabola is facing downwards, they want you to write your P as the positive value. So it's going to be P equals to positive 3. So that's this distance, of course, positive 3. But then you have to give the direction in which the parabola opens. So you will say that it opens down. Okay, so you will see questions on delta math where you have to specify what P is equal to, but then the direction. Since you're given the direction of the parabola opening down, they want you to write a positive value for P, regardless whether it opens to up, down, left, or right. Okay, so that's just on delta math how it was set up. I don't like this, but that's, I don't get a choice of how delta math is set up. Okay. All right, so once again, before I move on to our last example, are there any questions? Okay, if there are no questions, then let's move on. So our last example is, we're given an equation of the parabola, but please notice that our equation is not in standard form. It's in a completely expanded form. Y squared plus 6y plus 8x plus 25. So we need to write an equation in standard form. And by the standard form, we do mean one of these two one of the two forms that I showed earlier. So these forms that we've been writing equations in. So we want to rewrite the equation in standard form, and then after we do it, we want to find the vertex, the focus, the directrix, and sketch the graph. Okay, so let me rewrite the equation first. So we have y squared plus 6y plus 8x plus 25 equals 0. That's what's given to us. Well, by looking at this, this is where the whole idea of completing the square comes in. That's why we had to review completing the square first. On our first day back from the winter break, we had to remember how to complete the square in order to use it for questions like this. Now, in this case, notice we have two variables. We have both y and x, but x is not squared. So we cannot complete the square for the variable that is not squared. Therefore, we're going to complete the square only for the y, and everything else, this 8x and 25, we actually want to move to the other side. We don't need those values to complete the square. And when we move this to the other side, since we have positive 8x, we're going to subtract 8x, and the 25 we will also subtract. So right now, we're going to have y squared plus 6y plus, then we're going to remember to complete the square, we have to find that constant that will make it a perfect square. So we're going to use a blank space there, equals negative 8x minus 25. And remember, in order to balance the equation, if I'm going to add something on the left, we have to add the same value on the right. Now, to complete the square, remember we are looking for this, what we call a C term. And to do that, we're going to take the middle number, which is our B term, divided by 2, and then square it. So in this case, it would be 6 divided by 2 squared, which is 9. And once again, if we add 9 on the left, we have to add 9 on the right. Once we've done this expression that I'm highlighting, that is a perfect square. And just like we've done in class in the previous lesson, we can now condense it into a squared binomial. So we take a square root of the first term, which is y squared, so it becomes y. Then we use whatever sign we have in the middle, which is a plus. And we take a square root of the last term, so it's a square root of 9, which becomes 3. So we have y plus 3 squared equals. Now, on the right side, the only thing that we can do is we can combine the like terms. Negative 25 can be combined with 9. So we end up with negative 8x minus 16. Now, if you look at this expression, we can see that it still doesn't look like a standard form. In a standard form, we have x not having any coefficient in the front, and we have to have this expression for p in front of the parentheses. So to get there, whatever is the coefficient of x, in this case it's negative 8, we always have to factor it out. So therefore we have y plus 3 squared equals negative 8. And when we factor negative 8 out, in the parentheses we'll have x plus 2. So now this is our standard form. So that's the first part. Once we have the standard form, now this really becomes like the very first example that we've done. Now we can find the vertex. Then we can find the focus and directrix. Okay, now the vertex, remember that's your h and k. Remember that the number next to y is always k, and number next to x is always h, and remember to switch the signs. So your vertex will be negative 2, negative 3. So please be very careful of writing the vertex, especially when your form is when you have y first. A lot of students forget to switch a lot of students mix up the order of this two coordinates when the equation is in this form. In my other classes, when we did this in person, that's what happened with several students. So notice the x coordinate is always next to x, and the y coordinate is always next to y. And remember to switch the signs. So have negative 2, negative 3, and just like with the first example that we've been working on, we're going to plot this point on the graph. Negative 2, negative 3, that is our vertex. Now, by looking at this form, we should know the direction the parabola opens. Since y component is the one that's squared, it's opening horizontally. And since this number is negative, then 8 is negative, then it means that the parabola will open to the left. So from here, we know the parabola will open to the left. Now, that tells us, that allows us to find our focus and directrix. To find the focus, we need to find p. So remember that 4p is equal to this number in the front of the parentheses. So it's our negative 8. And then from here, we divide both sides by 4, and we get that p is equal to negative 2. So that means that we're going 2 units to the left. So this is our p equals negative 2. So this is our focus, and we can figure out the coordinates of the focus. So the coordinates of the focus are negative 4, negative 3. In a similar way, we can find the directrix, because the directrix is also the same distance from the vertex. So we also go in this -2 distance, but now opposite direction. So the directrix would be a vertical line like this. And remember the equation of a vertical line is always written as x equals the x-intercept. So this equation is x equals 0 in this case. So that is our directrix. And therefore, we have all parts of our parabola. Okay. So these are all of our examples. You can also find these filled out notes on Canvas if you need to look at those again. So the filled out notes are already there. Once again, please tell me if you have any questions before I dismiss this meeting. Okay, then I'll stop the share. And okay, here I am. Hi, everyone again. So at this point, I will stop the recording. Once I figure out how to do that. Okay.